Hello, everyone, and thank you for joining today's session. Uh, just let me know if I'm audible or not to you guys. Just say anything, whatever you like. Okay, thank you so much, Mary, for confirming that you are able to indeed able to hear me. So thank you again for joining this session. I've done a lot of training in the past, on my YouTube channel, where, pretty much I've recorded video. But this time I thought maybe, let's go ahead and introduce something like a live training where people can, get to ask more questions, and especially we all can do a knowledge share. It's not just like I knows everything. There may be people out there who have joined to this session, may definitely have some experience, or maybe there are candidates and attendees who has no experience with the Docker. So the whole idea behind this series is just to make sure you know what is Docker and how you can make use of the Docker in your day-to-day use, or how really you can get some more benefit by moving towards maybe like a Docker as your platform. Because if I give you a little details here, in the past, we pretty much used to deal with physical servers. So take an example, you bought some server, any brand, I just don't want to name anything, but let's say you bought a server A with maybe 16 gig of memory, a 500 gig of drive, maybe a quad core processor, and you decided to use maybe, let's say, Microsoft Exchanger application or MySQL database, or probably Oracle as database, or in some other application. So that's what traditionally we have been doing. So, but there was a problem with that approach. Now, let's say the application you install, there is no guarantee that the application will make use of the full resources on that physical server. So let's say you just went ahead and decided that I'll go ahead and make use of the MySQL. Probably your MySQL database is not large enough that it's making use of your full 500 gig of drive, or maybe your 16 gig of memory and a quad core processor. So you had a lot of CPU cycle, memory cycle, and the hard drive cycles wasted pretty much. Later on, from the physical server to utilize these physical resources in much better way, we kind of moved away from the physical and we moved it to the world of the virtualization. So traditionally, where we'll take a bare metal server, we go ahead and install a hypervisor. So now there are a lot of hypervisor out there. So you can use one of the most popular being, and I guess everyone knows is like VMware. So you can make use of your VMware vSphere ESXi. You can go ahead and install on top of your bare metal, and then you can start running your virtual machines. Or you can use something like Microsoft Hyper-V. If you are like an open source fan, just like me, so probably you can go ahead and use something like Zen. So you can go ahead and download any of those things and can start running that as a hypervisor. And once you have your hypervisor up and running, now pretty much you can go ahead and start creating virtual machines. So those, we can call them virtual machines or guest operating system. If you talk in the terms of the cloud technology, a lot of people like to call them instances. So yeah, you pretty much can create any type of instance. So that guest or your instance can pretty much running in any operating system. Like you can install a Linux on that one, probably a Windows, or any other kind of application that you decide. So again, the good thing with that approach was definitely, we say, we were able to make use of a lot of resources which were getting wasted earlier on the physical platform. That definitely improved a lot of things. But with that, there was a little problem that was introduced. Now, let's say, okay, hey, we have a development team and they are doing a development against the LAMP stack. So pretty much they are using Linux, Apache, MySQL, PHP, and they are working on an application, that needs to go production. So they decided to, so, you as an admin, they reached out to you saying, hey, we would need a server that runs a version of a LAMP stack. So let's say the version, whatever they gave, and then you go ahead and download the ISO. Probably you go ahead and use the Ubuntu, CentOS, or Red Hat, whatever is the flavor they are looking for. So we'll go ahead and install the full operating system, and on top of that full operating system, you would go ahead and install your different certain version of LAMP stack. And you just go ahead and deliver that LAMP stack and say, hey guys, your server is ready, go ahead and start accessing. And they said, okay, fair enough, thank you so much. Now, next day they come back and say, hey, we are making some tweaks, and we realized, when we requested this server that now there is another version of PHP came. We want to keep three of the components in the old version, but we just want to have a PHP on a different version. But at the same time, the another guy comes from the team says, hey, we want to keep the existing server that you gave us. Kindly go ahead and build a new server. So now what you have to do, you have to go and rebuild the whole server again. So you would have to go ahead and install the operating system again. You can definitely save some cycle. People can say, hey, we can save some cycle by creating a template. Obviously, you can go ahead and create a template. That definitely saves you some time in terms of the installation. But see here, one thing is very common every time you're doing that they are looking for one application that they are more interested in the LAMP stack. They are not really interested with the operating system. They requested you to have a specific version of the PHP. Now, when even you are cloning or installing, your system is installing your base operating system, which they may not be interested in. So what I'm trying to say here that so there is a space that is being consumed by your base operating system in terms of the physical drive, in terms of the memory, in terms of the CPU. So you are wasting a lot of resources over there. So that's where the whole idea of this Docker or the containerized thing came. Two things I just want to make clear that container is not a very new technology. It has been around for a while. And if we go back a really couple of decades back, and if you look back into 1979 or 1980s, during those times, we definitely had the Linux FreeBSD was out there. Sorry, it was not Linux, it was FreeBSD that was out there. FreeBSD came up with the concept of your CH root. So once you change your CH root, or you go to a different directory, that becomes your root. Now, what you do, everything is within that root. But again, that even with that CH root, you had full permission on the rest of your resources. So later on, things moved into, and then Google really came up with the concept of C group back into sometime around like 2000, late of 2006 or early 2007, where they came up with this concept of the C group, which you must know if you are working with Linux probably, they call it control groups. So the whole idea behind bringing those control group that, okay, hey, now, before really the control group came, there was some other things were introduced that would allow you to segregate your resources. So now you will have a different groups to control. So you will have like a namespace for a net. You will have one for namespace that will handle your namespace. You will have something for the IO control. Same thing that will go with your network namespace. So the whole idea behind the control group when it came, because without the control group, okay, you can definitely go ahead and partition your CPU, memory, and hard drive. But there was no such concept where you can say, hey, when I'm partitioning, I want to have this partition X amount of CPU, or I want to have this being prioritized versus the other one. Same thing, I want to have this particular container more amount of memory versus the other one. And same thing goes with the IO as well as network. So when C group or the control groups came into the picture, that was the time this whole capability was added where you can allocate and prioritize your CPU, memory, IO, and network. So on those things, then it's pretty much, that has gave us like a complete isolation at the operating system level. That's what a lot of people call it operating system virtualization too. It's different from what you do like when you install ESXi or Hyper-V or XAMPP. So that's the whole idea behind the operating system level virtualization, where we are keeping the same kernel, but we are dividing all of these network namespace, all of these namespace, CPU, memory, IO, network, process, all of different namespace. So we are making them isolated. So So everyone runs their own process and they don't know if there are any other process running on the same host. So that was the whole idea, bringing up all of these different C group and names, your name groups. Any questions, guys? So far, anything what we just talked about, that's just pretty normal. Okay. So, well, go. Let me go ahead and start sharing my screen, and I'll just go through some of the basic things that we pretty much. I feel it's pretty important, before we really go ahead and start doing anything. So, hopefully, my screen is visible to you guys. What I'm sharing right now, I'm sharing my Chrome, and within the Chrome, I'm sharing certain documents probably. So, you guys should be able to see. So let's go back and look at some of the official definitions around the, containers really. When you talk to a lot of people, people think, okay, hey, containers are but nothing but just like virtual machines. So this is one of the blog article written by one of the Docker guy by name Mike. So, thanks to him, he gave us pretty good insight into this one. Because you talk to anyone and the first person most of the people will say, okay, hey, the Docker, yeah, they're nothing pretty much, like a virtual machine. But it's not a virtual machine, guys. So there is a good detail into this one, and I can share the URL later. But if you look here, especially, so Docker containers, are nothing but as you can think of as a lightweight VMs. Okay, they are very lightweight compared to your traditional VM because, like as I mentioned earlier, in the traditional VM, you would have to install the whole operating system, and then on top of that whole operating system, you would go ahead and install your desired application that you are looking for. So while that's not the case with the Docker. Because as I said, it's everybody gets it the first time. Everyone thinks at the first time, okay, hey, Docker is nothing again, it's a VM. But there are a few things that needs to be clarified. Okay, both are designed. So when it says both, he's referencing here as a virtual machine, a traditional virtual machine versus your Docker container. So now onwards, can say Docker container or container. So I'm always referring to Docker container, guys. So something just to remember. So both are designed. So the VM as well as the Docker container are designed to provide an isolated environment in which to run an application that we know. So you can go ahead and bring up you can create a VM, you can run Ubuntu, you can run CentOS, you can run a Windows server probably. Same thing we can do with the container. We'll get to learn later in this series. Additionally, in both cases, that environment is represented as a binary abstract that can move between hosts. So when it says move between hosts, so you create a VM, and let's say you have multiple ESXi or Hyper-V clusters and cluster. You can do a vMotion. You can migrate your virtual machine from one host to the another, and same thing can be done with your Docker container. And there are there are many more similarities. Okay, but there are few things that needs to be remembered here. So now this paragraph is one of my favorites. So that will give you more detail. So when we talk about the VM, think of it like as in a houses. Okay. So when it says the houses, now we're talking like an independent house. It's not something like a bigger community. Like our old days or old traditional homes. Everyone had almost, I won't say everyone here, but pretty much our parents and grandparents, everyone had their own homes. So the homes or the houses are like fully contained and offer protection from unwanted guests. So that means they also possess their own infrastructure. So like we have our own heating, electricity, plumbing, and everything. And one house can have multiple bedrooms too. So there is a living room, there is a bathroom, and there is a kitchen. And there are many more other things. While on the other hand, so remember, guys, the houses we are, houses to the VMs. So it says the house is the main important thing to remember that they are self-contained and possess their own infrastructure. These are the two important things need to be remembered. While on the other hand, if you look, what are the containers actually? So here he's comparing the containers to the apartments. So when he's talking about apartments, so the apartments are usually in clusters. So there are multiple apartments within building. So now, if you see now now there could be one apartment, there could be one building that may has like maybe 10 apartments or more than that. And again, you can create there may be multiple buildings that could make up a whole society. So the whole analogy here to see the apartments are the containers that offer protection from unwanted guests. Okay, it's the same thing what the house is doing, but they are built around a shared infrastructure. That's the main important thing: shared infrastructure. Why it is a shared infrastructure? Now, even though every apartment has their front doors, okay, but anyone can come to anyone's up to the front door. Obviously, they may not be able to get inside your apartment, but they can definitely come up to your front door. So that means it's not protected. So you don't have a special protection around your own apartment. So you are relying on a shared infrastructure, which is like probably your society's main gate, which is shared by every apartment. So it's not dedicated to you pretty much. So that is being shared. So the main thing to remember when we talk about the container, the shared infrastructure. So while in the case of the home, we had our main gate, so no one can come inside that. So you can think, or now you can say, oh, that house is just like an apartment. But like as I said, how for your apartment, the main door is like a shared by all those apartments pretty much. So now the same thing here, it says the apartment building. Now the whole apartment building, we are calling it as a Docker host. So we are comparing the apartment building to a machine which is running your Docker. And the machine which is running your Docker server or Docker engine, we will get to learn them later. We call them Docker host. So those are the machine where we are running our Docker server or engine. Now again, we discussed, as we shared earlier mentioned, is the whole thing is around is the shared infrastructure. Everything is being shared. So there are a lot of examples being shared. Okay, there is a shared pool, there is a shared elevator, there may be a shared backup generator, or some of those things. So like last line, what it says on this paragraph, finally, just like houses, apartment have front doors that keep locked to keep unwanted guests. So again, apartment does have those doors too. So again, those were just to the two bigger picture, just to familiarize yourself. Okay, hey, what are we talking when we say VM is fully self-contained, has its own infrastructure, while containers, relies on the shared infrastructure. They don't have everything of their own. So now this next paragraph clearly says with container, you share the underlying resources of the Docker host. So that's the whole idea that you are sharing. So all the machines, all the containers which are running on this host, they all share that host resources. Now, if we go back a little bit and what we understood that was the C group. So now let's say on a host, I'm running a Docker host and where I created multiple containers. I could have some test containers which I'm just using for testing, or I can run some production application. So when you're running some production application, you want to make sure, okay, hey, those containers are given high priority in terms of the memory, CPU, hard drive space, or any kind of other thing. That's where the whole concept of the C group comes in. You can assign C groups, so that way you can prioritize certain things on certain of your containers. That's the whole idea. Uh, so again, the containers shares the underlying resources of your host, and you build an image that is exactly what you need to run your application. And we'll get to see them during in the hands-on. Again, there are a lot of people, like who we have been using VMs. Okay, we can use some third-party application to take a backup of a VM. We can definitely use a similar approach, and we can go ahead and back up our containers and all. Again, there is quite a good details onto this article. I'm not going to read everything, but yeah, I just wanted to make two things very clear. The VM has everything, self-contained and their own infrastructure, while the container pretty much relies on the shared infrastructure. And that's where the whole power comes into the picture, that we don't have to reinstall the host operating system again. We will be using the existing host operating system. And on top of that, we'll go ahead and create our own containers. And within that container, we can go ahead and now run any kind of operating system pretty much which is supported as of right now. So Docker, as of today, we can run on Linux, we can run on Windows, we can run on Mac OS. So yeah, pretty much it's supported across everything. There is another blog article. I'll not read again many of these details, but this is again one of another very good blog, that has a very good details around some of these things what we discussed. And in this blog, I just want to highlight, one thing. So what are containers and VM? Again, we know a little bit again. Containers and VM, we know they are similar to their goals to isolate an application. That what we just learned. Moreover, container and VM remove the need of physical hardware. Obviously, both are virtual. So the Dockers are also runs on top of an operating system. Could be Linux, Windows, or Mac, as we said earlier. And same thing on top of that, you will go ahead and create your containers. So both are, there is no need for physical things. Everything is virtual. So now, if both in they're both the cases, if everything is virtual, so where is the difference actually? So again, there is a good lot of detail. I'm not going to run all the details, but yeah, this blog has pretty good detail around some of these things. So let me just show you a few pictures here. Maybe pretty helpful. I'll make it a little small so you guys can, hopefully it's visible to everyone. Okay. So in the traditional one, you would have a server, take any server. On top of that server, you will go ahead and install a host operating system. And then once that, then you will have a hypervisor like either ESXi. So ESXi also has its own small operating system, or you can go ahead and make use of the Zen, KVM, Hyper-V, anything. Once that is done, on top of that, then you will go ahead and start creating your VMs. So once you start your VMs, you will have to install a guest operating system, and then you will need to install your necessary binaries and library files. And after that, you will go ahead and install your applications that you need. The example we took that was for the LAMP stack. So we'll go ahead and install your LAMP stack in that case. But even though we were most interested in the LAMP stack, we still had to go through this whole process of installing the guest operating system, necessary binaries and library files. While on the container, so this thing is pretty good again. The one big difference between container and VM is that container share. That's what we learned from the other article. So now when it says share, if you see here that we do have a server here, we do have a host operating system, which if you look back is exactly same two layers what we saw in the traditional approach also. But now, instead of here in the traditional approach, we had a hypervisor. Now, instead of the hypervisor, we installed something called as a Docker engine or Docker server. So this is the application or the library or the binary that you install that allows you to create these containers, or we call them Docker containers. Now, once you have this Docker engine or Docker server or Docker daemon running on your host operating system, now you can just go ahead and create those containers. So now when you bring up your container, the container, you will just need to have necessary binary and library. And then on top of that, you will go ahead and install your applications. So that way you don't have to install any more this guest operating system, saving a lot of space. And also at the same time, it increases your overall efficiency and your overall speed you can think of in one way. So now if let's say somebody says, okay, hey, I want to have 3 instances of LAMP stack with different version of certain application or certain project. Let's say, okay, hey, I want to have Apache 2.0 here, maybe 2.1 here, 2.2 here, or something of that nature. With the VM, certainly we can do that, but again, there is a cost we are paying in terms of the installing the guest operating system. While on the Docker container, we don't have to do that. We are always using the your host operating system. So that's the whole another terminology you can think of for your OS level virtualization. So hopefully these two pictures make more sense. Again, there are lots of things. I'm not going to go and read everything, but yeah, definitely I'll go back and we'll talk about this little picture here. So we just discussed you will pick a server where you will go ahead and install the Docker binary. And that Docker binary, you can call that as your Docker host. We can call that as Docker server or Docker engine. So there are multiple things you can get. So when you install your server, by default, you can manage that server. We gets installed with the client also. So you can log in directly to the server and you can start creating the container itself on that server. Or you can have a dedicated client which can talk to your server over IP network, and that's how also you can manage. So that means if you have, let's say, multiple Docker hosts, it makes more sense to have a dedicated client. That way you can talk to multiple hosts and can do a lot of things. So now, if we take an example, let's say you take an example of any kind of operating system, let's say Windows, Linux, or anything. So anytime there is let's say new patch comes in case of Microsoft, if there is new patch comes in, you go to Microsoft website, you download that patch, and then install on your machine. You are trying to install a new Linux machine. you would go to certain distribution website, Ubuntu or CentOS, and you would go ahead and download an ISO and go ahead and install that. And after that, if you need to upgrade, you will go ahead and download certain patches from those websites. Use of doing either yum or apt-get or anything that you decide. So you are downloading those things from a place that we call in journal as a repository. Some people call it like, okay, hey, this is the download site, from where we download this ISO. So the technical term for that is like a repository. So same thing for your Docker, from where you can go ahead and download some pre-built Docker images, or you can create your own images and also share with others. So the place there where we go can go ahead and download those images, or that repository, we call it as a Docker registry. So you can go ahead and by default, once you install the Docker host, it always points back to the official Docker registry, which is your hub.docker.org. You can install your private repository also inside your company if you decide so. So that way, not everybody is trying to go to the internet and trying to download the stuff. So, or you can have both private and public. So just remember again, we'll talk about these in more greater details later, but just wanted to make sure that you know what is Docker registry, what is Docker host, and what is Docker client. Okay, I'll take a pause here. If there are any questions, I like to get them answered. So let me go ahead and look at my chat here, guys. Okay, guys. So just give me one more time thumbs up, guys, if you're still able to hear me, because I just moved to a different network so we can access our Docker host so we can do some practical here. Anyone just, give me a hi or yes that you're still able to hear me. Thank you. Anyone? Okay, perfect. Thank you, Mary. Really appreciate it. Okay, guys, so let me go ahead and give you a little more detail here. Again, we talked about in journal, the Linux containers, the secret, and that was the whole idea, from where we kind of pretty much, derived everything. So let me go ahead and share some other things with you guys. Okay, I hope this is visible to everyone. And again, if not, just let me know if there are any problem. Thank you again. So let's go ahead and talk about. So let's quickly talk about Alexi. I again don't want to spend more time. Alexi is just a general terminology for your Linux containers. And again, it's pretty easy to use. We have been, talked about multiple times that your Alexi is a Linux containers and operating system level virtualization pretty much. And it's one of the ways that allows you to run an isolated Linux system or containers on any of your operating system pretty much. And then we talked about the C groups. There are multiple C groups, the control groups. So like there is CPU, memory, IO, network. And again, there is one important pretty much is the process ID one. Again, you can go to the Wikipedia and look for Linux namespaces that will give you much greater details about these two things. And that's where the whole power comes into when we combine the LXC, which is Linux container, with the C group and with the isolated namespace. Those are some of the things. So the Docker, when initially the Docker came in, okay, sorry guys, okay, it's a small, let me go ahead and increase the font size. Okay, is that better, guys? Okay, hope should be better now. If not, let me go ahead and increase my font size a little bit. Hopefully that should do the trick. So like I was mentioning earlier, when Docker came in, it was using LXC, the Linux container, as one of its execution driver. So that was the whole idea. So, you will have your physical resources in terms of your CPU, memory, hard drive. And initially when it came, it was definitely only on the Linux side. So you will see the Linux kernel. And on the Linux kernel level, we had all of these different namespaces that we just discussed a few minutes earlier. CPU, memory, network, IO, and your PID namespace. So now, when the Docker engine came in, Docker engine was using Alexi as one of the mechanisms to communicate with these C groups. And they came up with this library that was the libcontainer library that was kind of relying, say they were pretty much heavily were relying on this libcontainer library to communicate back to the operating system to these different namespaces. That was kind of a dependency for them. So in the new approach, in the later release, what they did, they came up with their own lib container that comes as a part of your Docker engine. So that way they are not relying anymore on any kind of another third party you can think of or any more dependency. That way you have everything within the Docker engine that you need to run your containers. So that way you just go ahead and install your Docker container, and there is a certain version of lib container that will make sure that you can communicate back to all of these namespaces. And they were still using the Alexi, and then they came up with another approach also. And some of the default driver, because when they moved this thing, the default driver execution is lib container, and we'll get to see them during the hands-on too. That yeah, this is the new version is indeed using the lib container. Okay, so you guys good. Quick look, this diagram just shows you here that pretty much you can run your Docker engine, your Docker or Docker engine, guys. You can go ahead and install on your laptop. Like as I said, it's supported pretty much on Windows, Linux, or Mac OS. And again, it doesn't need much of the resource on Windows side. You can go ahead and install like a VirtualBox. You can go ahead and make use of Vagrant. On the Mac side, you can go ahead and install, or there are some tools available, so you can go ahead and use that. There are popular, public cloud that also supports your Docker engine. So something like Amazon Web Server, Microsoft Azure, they all supports your Docker engine. So that means you can go ahead and install a Docker on your laptop. You can create a container, test that container. Once you're happy, you think, okay, hey, now my application looks good. I'm good to go production. Everything looks nice. Okay, now you can take that Docker container that you created here, and you can move it. Let's say you are on one of the public cloud, you can move to that public cloud. So now the good thing that because the Docker is so independent, it has no relationship or it has no dependency with the hardware in any way or anything. As long as there is a Docker engine, and pretty much it supports most of the cross versioning too, so that's fine. So go ahead and create a container. You can easily migrate or ship that container from one, like in this case your laptop, to one of the public cloud, or maybe to your a data center. So that's the whole flexibility behind running these Docker containers, because here this Docker engine is the agnostic layer, because from the Docker's containers point of view, as long as there is a Docker engine, that's fine. So Docker container only looks for the Docker engine. We don't, it has no visibility to the underneath. Oh, is it running on laptop or AWS, Azure, or your own from data center? Pretty much. So that's pretty cool thing about the Docker container. So it's kind of, just create anywhere, wherever you like. And once things are at according the way you want, and then just move it into your production, either onto your on-premise data center or maybe to public data center. And with the, as Docker evolved over a period of time, there are different things, they came up with. Initially, they started pretty much with the Docker engine based on LXC, then came up with their own approach of lib container. And then slowly, they came up with a lot of different things. So there is a registry. We just talked about registry in place, where you can go ahead and download some of the Docker images, or you can go ahead and create your own images and share with the rest of the world. So that's what they call it as a Docker hub. You can definitely do a clustering with the Docker. So let's say, okay, hey, people think, okay, it's a VM or it's a container. How about, can we create a high available fault tolerant application with that? Absolutely. Docker does support clustering. So you can create a cluster of multiple Docker hosts. You can create multiple container and do like clustering, or, whatever, that's active standby, active, whatever your application support, that kind of clustering. You can definitely use orchestration. There is something called as a Docker Compose. For the clustering, the official terminology is Docker Swarm. For the Docker Compose is something, okay, hey, let's say we took an example earlier. You have a dev team, they are doing some LAMP application, and there is a demand, they want probably like a LAMP stack server every day or so something. So you can go ahead and orchestrate. So that means you can go ahead and create our files and just pass those files back to your Docker Compose, and that will take care of bringing up the necessary resources. In the first version, there was no support for multi-host networking. So that means if there are two hosts and you have one container running on one host that wants to communicate with a container on the another host, probably let's say you're making a two-tier application, and database and web. Web is on one host and DB on another host. There was no such thing. Now they do support multi-host network switching, so that's something is with the libchan library. So that's another thing. And there has been, many more things has came out, after this too. This diagram is not very updated. So again, I will take a quick pause here and just see if there are anything. Can we Docker in private cloud? Absolutely, yeah, yeah. So you can go ahead and do it in the OpenStack also. So you can use the OpenStack as your hypervisor, just like maybe you will use maybe VMware or your KVM or Hyper-V. So you can run the OpenStack, so you can use the Nova, and on top of those, then you can go ahead and create your Docker engine. And once you have a Docker engine, on top of that, you can go ahead and create containers. But if you take a little back here, kind of on the back end, it utilizes your, the Zen or the KVM, what we call. So on the Zen, you will go ahead and create a VM, and that VM will be nothing your Docker host. Now, on top of that, your Docker host, you can certainly go ahead and start run your more containers. So yeah, there is no such restriction. You can certainly do that. But yeah, from design point of view or from production point of view, do you really want to do that? That's a different question, because like, okay, you already have an hypervisor, and again on top of that hypervisor, you are again trying to virtualize more stuff. So that would be something goes back as a design question, and okay, hey, will that make more sense? But yeah, in terms of the practicality from technical point of view, certainly, yeah, that's definitely can be done. Yeah. No, thanks for question. Yeah, keep coming questions, guys. If you have anything you want to ask, thank you again. So now let's go back, and I think I'll take a little pause here. As I said, I'm looking at some of the questions if anyone has. And I see there are people on the Hangout too. Yeah, guys, if you like to talk in, like, go ahead and unmute your microphones and you can ask, or you can go ahead and post in the Q&A, whatever is convenient if you guys have any questions. Okay, so I'll go ahead and stop. I'll go ahead and stop sharing this one. I'll go ahead and start sharing my Docker host with you guys. Give me a second. Just let me go ahead and log in quickly to my Docker host. So let me go ahead and share my Docker host with you guys. Okay, guys. Hopefully, my terminal window should be visible to everyone. And again, if not, just post in chat so I know. So let me just go ahead and show you that I logged on to one of my Docker hosts. And just an FYI, I've already done installation of a Docker host. I will show you the steps, that I ran. So I just wanted to show you that the base operating system that which is running on this physical bare metal server, I'm using Ubuntu 14.04 LTS, the long-term, release pretty much. And once you have done the installation of your Docker, you will get to see a new interface gets created automatically on your host machine, which is your Docker Zero. And once that gets created, it automatically gets assigned an IP address. So how that IP address gets assigned, it looks up both, all the physical NIC on the machine and sees, okay, hey, this subnet is not in use. So it'll go ahead and picks up a random subnet pretty much. So that's what you see in the Docker Zero. So on this machine, as I said, there is a Docker installation is already done. Doing a Docker installation is very easy. Once you go ahead and install your base operating system, make sure you go ahead and update that. So in my case, I'm running Ubuntu, so I would go ahead and run something like sudo apt-get update, and probably after that upgrade. If you are running CentOS, you can go ahead and do a yum update, or some of the same other similar other things. Once that is done, make sure that the host that you're using for your Docker host can reach the internet. So pretty much try going to any of the URLs, just do a ping to like Cisco.com, Google.com, Yahoo.com, anything whichever your favorite, just to make sure, yeah, you do have a definitely good internet connectivity. Once that is done, after that, you will need to go ahead and install the Docker engine or Docker daemon onto your host. So in this case, as you can see, I went ahead and ran this command earlier, which is your sudo. And I'm sure you guys understand why I'm writing sudo. So I'll have the root privileges. I'm elevating my privileges to run this particular command. And this apt-get is my installer, so which is on the Ubuntu. So I'm running apt-get install and -y. Okay, I don't have to say go ahead and install. So it will automatically go ahead and accept this one. And this is the package on the Ubuntu that I'm using. So just a note for the, if you guys decide to use Ubuntu, there are two packages for Docker on the Ubuntu. If you just type Docker, you will go ahead and download the old version, which is LXC based. If you want a new version, you would have to type the docker.io. That will go ahead and fetch the new, which is your lib container base. So something just to keep in mind. But again, I would highly encourage going back to the Docker official website to see what is latest out there and in the instruction in terms of installing the Docker. Once the Docker has been installed, okay, there are few things that you can go ahead and run. So now let me go ahead and I'll go ahead and run again all the commands. I'm typing sudo here, and the first command I'm typing is the version. And let me go ahead and enter it. So once you run the Docker version command, the Docker version command will show you a couple of things. Let's look up here. The first thing that says the server version. So my server, the version of the Docker server that I'm running on this host is 162. And if you look at the first second line that was just showed up, the client version is also 160. So the client version and the server version always matches when you install a Docker client and server, something to remember. And the version of the Go, the Docker was, programmed a lot of things, or in the backend uses Google's Go programming language, and that's where you get to see the version of the Go here. So the version of the Golang that is being used for this version is 1.21. Something just to keep in mind. This is the API version, the architecture that I'm running here, and some of the other details. Yeah, pretty handy command, not much thing, but definitely a very good command to keep in mind, and go ahead and run a few things. So the Docker version just gives you some very basic information. If you're looking for more details, go ahead and run the Docker info command. So when you run Docker info, it will give you a little more details like this. So it shows you, okay, hey, are there any containers? And if there are already existing container in machine, how many number of containers? So it shows, okay, hey, on this machine, on this host, there are 6 containers. There are 38 images. So guys, just remember image for the time being. You can just think of just like an ISO or your binaries to install your, let's say, Linux or Windows, something. For the time being, we'll go ahead and talk about the images later on in much more great details. On the Ubuntu, Docker uses your AUFS as a file system. So it's your union file system, and we'll talk about what is unique about union file system later. The root directory here is the warlib docker AUFS. So when you run a Docker, the file system where it gets, the root and all, it's on this particular directory. Execution driver, as you can see, the execution driver here, it says the native. So native means here, guys, we are using lib containers. If I had installed this, the apt-get, installed Docker instead of docker.io, I will go ahead and download the old version. And the old version, if you remember, or that relies on the LXC. So in my case, instead of native, I will get to see here as LXC instead of native. So native, when somebody says, okay, hey, the Docker is running with the execution driver native, that means we are talking with the lib container that comes with the Docker container or Docker server, Docker engine. And it tells me, okay, hey, my operating system is Ubuntu 14.04. There is one physical CPU on this machine. There is a 2 gig of memory. This is the name of the machine. And these are some of the other details. So hopefully make more sense. Definitely with the Docker info, you can certainly get more details and, pretty handy command, to look certain things. Let's run one more command here. We'll go ahead and run sudo no vram, and like I said, I'm running with the all these commands with the elevated privileges. If I just do a docker info, I mean, yeah. So because I have configured this local user as part of my root group too. By default, when you install a Docker, remember, it runs everything as a root, and it becomes part of the root group user. So if you want to run the Docker engine or Docker or daemon within a different user and group, go ahead and add that once you install. I'll go ahead and show you all that information. So you can use the your user mode command -ang Docker group, and you can go ahead and add your local user. In my case, I added my local admin to be part of the Docker group. And you can go ahead and verify that by just running the ID command. And as you can see, my local admin user is part of the Docker group. That's why I am able to run the command docker info without elevated privileges. If the local admin was not added part of the Docker group, if I try to run just the Docker info, I will, throw me error saying, okay, I cannot run because you don't have permission and some of the other details. So yeah, something just to keep in mind. You can run docker-v. I'll give you the short version, whatever we saw earlier, the version. If you're just interested in quickly looking, okay, hey, what is the version of Docker I'm running? Go ahead and type the docker-v command. So it's pretty again handy, some of these things. And as I mentioned earlier, the AUFS, we'll talk about in much more greater detail, but remember something, AUFS stands for your another union file system. That's the implementation that is being used on the Ubuntu. If you go back and look at something like CentOS or Red Hat, they don't have the AUFS, and pretty much, they make use of your mapper device just to mimic the AUFS. So that means you will have a performance hit if you are trying to run the Docker in production on either CentOS or Red Hat if they don't have a native support for AUFS. Something to keep in mind. Again, we'll talk a little bit more in details, but yeah, I would certainly encourage you to go and read a bit more about the AUFS. You can just go to any of your search engine, whatever you like, and then just type AUFS. I will give you enough detail probably for you to get started, and we'll give you some good details. Again, just I mentioned earlier, one more time, I just want to repeat. The other OS uses your device mapper, and also you will have a performance hit on that. So as you saw that, this machine is my server as well as I'm doing all the commands on this one. So when I run the command, I'm using the Docker client, and in the back, I'm sending these commands to the Docker client. The Docker client takes all of these commands and talks to the Docker engine, and that's how the Docker engine, the daemon, is returning all of this information. So now let's go ahead and run another command, docker ps. I'll go ahead and type a docker ps command. Docker-ps is pretty much says, okay, hey, are there any running container on this host? So if there are any running containers, it will show you here when you type a docker ps command. Let's say you created some containers and later on you just exited or you stopped all those containers. If you want to see all the containers, no matter whether they are running or they are stopped, you can go ahead and repeat the same command, docker-ps, and you can go ahead and append here -a. That will give you a good details about, okay, hey, these are the Docker containers, that we ran pretty much. So let me go ahead and expand a little better. And let me run this command. Okay, perfect. So when we are running this Docker ps-a command, it shows you all dash a pretty much all. So it shows you all of your Docker containers. Give me a second, guys. Okay. Okay, yeah. So the first column says container ID. Anytime when you launch a Docker container, Docker randomly assigns a container ID. So that's where you see this alphanumeric pretty much. That's your Docker ID. The second column says the image. As I said, think of an image right now as an ISO that was used for the creation of this container. So this is the my container ID. This is the image that I use for the creation of my container. If you see in the image, there are two parts. The first part, there is a colon, and there is a second part. The first part is the image name that was used. The second part, where you see there are a couple of images says latest, but there is image that says 1.1. So the part after the colon is really the version number. So I can have multiple version of an operating system, like the Windows 2008, R1, R2, or there's something else. Similarly, for my Ubuntu, I could have Ubuntu 14.04, 15.04, 16, 12, anything. Wherever you see latest, that means when this container was created, whatever the latest image was available on the Docker Hub, we used that image to create this container. That's why we see here latest. Hey, we pulled or we downloaded the latest image that time. You can download multiple images, as I said again, and if you will have multiple image, we'll see how to deal with them too. But yeah, just remember Docker ps-a shows you all the container that you ran. The next column shows command. Okay, what was the command that we ran against your container? When that particular container was created, what is the status of that container? Are there any ports that are being shared or exposed by this container? And the last column you see name. If you see some of these container has some a meaningful name like website, DBMS, but then there are some container where you see some funky names like Gloomy Pain, Hierogant. So there's another thing with the Docker. When you create a Docker container, if you don't specify a name, Docker will pick a randomly generated name. So if you're testing, that's fine, there's no problem. But if you are doing some kind of production environment, make sure to name your containers appropriately. Just something to keep in mind. You can, instead of dash a, you can use dash L also. So dash L will show you the last one the last one we dealt with instead of showing all. I guess so far so good. If there are any questions, again, just post them into the chat, and I'll have a look on those questions. Now we have been talking about so now if we go back again to create a VM, the first thing we needed is what? An IS or something. Based on that, you can go ahead and build your virtual machine. Same thing goes with your container. So if you want to create a container, the first thing probably would need an image that we have been talking. So from where do we get that image? And we just talked about earlier, you can go ahead and download those images from official public repository of a Docker, which is a Docker Hub. And when you install your Docker engine or server, it's pre-configured to point to that public repository. So in that repository, there are public images and there are private images. So by default, you can go ahead and download any public image, but you may not be able to download a private image. So if you have special access, you can go ahead and do that. Same thing, you can create your own private images, which is only for you or your company. You can go ahead and create some public image and share with the rest of the world. It's up to you. So now let's go ahead and run and see on this host, are there any images? So you would go ahead and type a command docker space images. So once I run that command, it says, okay, hey, on this host, I find that these are the images. And These are the images that are available on this Docker host. So that means in the past, somebody went in and downloaded all of these images. The first column, the repository, is really your image name. So you can see there is an image by name Nginx. We have an image by name Hello World. There is an image by name Postgres. There is an image by name Ubuntu. There is an image by name Arun test image. And the second column is the tag that we discussed, which is really a version number. These images, these were their latest version was downloaded. That's why you see the latest. But for these images, as you can see, I have version 1.0, 1.1. That means the same image, but they have a different version. So that means probably this image may have some more things which this image is missing. Third column is your image ID, again, your alphanumeric, when this was created, and what is the size of this image. So if you look here, guys, look at the Ubuntu image. This Ubuntu Docker image is only 188 MB. So even if you decide to go ahead and create a virtual machine with the minimal, the base, I am sure it will be way more bigger than 188 MB. So you can see automatically you are saving a lot on the storage also here. And downloading an image is very easy. So in this case, let's say, as I said, uh, let's go ahead and download maybe Nginx. So I'll go ahead and remove. So if you have downloaded an image, I will show you again, but probably I just want to. So if you want to remove an image, you can use the Docker RMI command. I'm sure it's a remove. I stands for your image. And go ahead and give your image name. So I'll go ahead and type the image name as Nginx. So I'm just saying, okay, hey, I just want to go ahead and delete this image. And as you can see, it says, okay, hey, deleted all of these things. And I just want you to remember, if you can, that when I ran this command, you see there are multiple deleted things. 1, 2, 3, 4, 5, 6, 7, 8. But I just deleted one thing, but it literally shows me, some of the 8 things were deleted. So now let's go ahead and learn, how do you really get the new image. So if you want to get a new image, it's pretty easy. But as I said earlier, now I knew the name of the image is Ubuntu. I knew the name of the image is Nginx. I knew the name of the image Hello World, which exists on the public repository. But let's say you don't know the name and you want to download an image. So how do you do that? You can use another cool command on the Docker, which is your Docker search command. Now let's say, okay, hey, we wanted to download Nginx. So let's see what is out there for Nginx. And you can go ahead and type the command. So I type Docker space search space Nginx. So what are we doing? We are going and doing a search on the official repository and looking anything that is a keyword Nginx. And you see the first line that says Nginx here. It says description official build of Nginx. That means if I go ahead and just type Nginx, so that means I will be downloading the official image which is provided by the Nginx. That means I know I can rely on this one. This directly comes from the main vendor. There has not been any change. But if you see, apart from this image, there are so many other images which claims to have Nginx. If you look at the second image, probably it says, okay, hey, automated Nginx. So this image also has Nginx. But if you see, it says it's an Nginx proxy, and there is a name here which says J Wilder. So that means this is a username of someone, and this guy has created his own Nginx image and has uploaded that image to the Docker Hub. And when you are doing a search, that's how you are getting this image. So just a piece of advice here: whenever you decide to download someone's image, just read their reviews and some of the other thing, because you definitely don't want to download someone else's image for a production. You never know what's inside that image. So just something keep in mind. There is no harm, as I said, like if you go back and look, always look at the number of star. If you see this image has been downloaded multiple times and there are definitely reviews, go ahead and read those before you decided to download someone else's image. But yeah, if I want to download this image, we have to use this as the image name. While if you want to download the official, I would go ahead and just type Nginx. Hopefully that makes sense to you guys. So now let's go ahead and download our first image. So now we'll go ahead and download the official Nginx image. So how do we do that? We'll go ahead and use the Docker again. To download an image, we'll use the keyword pull. Pull says, okay, hey, we want to download this image. And the image name, Nginx in our case. So I'll go ahead and say Docker pull Nginx. So let's go ahead and type this command and see what happens. So if you see that I'm starting to download, and if there are multiple downloads going on within this, downloading 51, then it says extracting, then it's again going to do some download, and then it's doing again extract, and you say my image was done. It was pretty quick, guys, and I'm not doing any, it's everything in real time. I'm not doing like recorded video or anything. So if I run the again here, Docker images command, and now you can see in my repository, boom, I have this Nginx image. And we just downloaded like 182 MB image in pretty quick second. But just remember something, when we downloaded this thing, again, it downloaded the Nginx latest because we didn't specify what is the version we want to download. So it always, if you don't specify a version, it always pulls the latest image. And as you can see, part of this image, there were a couple of these things, say pull complete, pull complete, pull complete, pull complete. Something just to keep in mind, and we'll talk about these in much more greater details. So we went ahead and downloaded Nginx image. Similarly, if you want, we can go ahead and download some more images. So let's go ahead and do a Docker pull on CentOS. CentOS tends to be a little big, so we'll take a few minutes. Again, when I say few minutes, it won't be very long, hardly a minute. Yeah, that machine has, guys, a way above, like 1 gig of internet connection. So that's the reason you see those images gets, downloaded pretty quick. So I'll go ahead and do a Docker images. And as you can see, the CentOS was also downloaded, was again 200 MB image, I guess few seconds probably. But now you can see how easy it is to download an image that you can use later on for the creation of your Docker containers. I'd like to take a quick pause and see if there is any questions or anything. Okay, so once the images are downloaded, now let me just show you one more thing here, and we're not going to do that, but I'll just show you. If you recall, if you don't know about any image, we can go ahead and type the Docker search command, and let's go ahead and type Ubuntu and see what happens in this case. When I ran that command, again as expected, we got multiple outputs here. Okay, Ubuntu and some of the other things. You want to download all the images, which would be crazy to say, but yeah, let's say hypothetically, if you want to download all the images that says Ubuntu, you can go ahead and type docker-a pull and the image name. That would go ahead and download all the images of Ubuntu out there. So yeah, just something, a fun command just to keep in mind, but I guess, nobody likes to do that probably. So Docker images again, just to see, okay, hey, these are the images that we have. Now let's go ahead and run our first container. So anything that we start with, even any programming language or anything, we always like to, start with something like hello world. I guess, that's pretty famous. So let's go ahead and create our first container. Creating a container is very easy. Again, you just need to make sure that the container that you want to run, we have an image available. Let's say you decided to run a container, but the image was not available. So that run command does that for you automatically. That means you told the Docker to create a container, but there is no image for that one. So it will go ahead and download that image first, and then it will go ahead and create the container. So it's pretty cool that way. So it will not error out or anything. Says, okay, hey, this image is not there, so I'm not going to run or something like that. So go ahead and type your Docker command. Once you type the Docker, you would say here run. That hey, I want to run a Docker container. Okay. With the Docker container, there are many things that you can do after a run command. We can run the Docker container in the background or detached mode, or we can run the Docker container into form of an interactive shell. So I'll go ahead and put here dash I as interactive and T as a TTY, so I want to have a TTY. After that, we need to tell the image that we wants to use for this Docker container. So let's say in this case, I want to use the CentOS image that we just downloaded. Okay. Now we are telling the Docker, hey, go ahead and create a container which is based on the CentOS image, and we want to have interactive and TTY. But what do you want to run? We are telling the Docker container that we want to run bin bash as the process. Okay. So let's see what happens once you do that. And before I do that, guys, let me cancel this one. I'm just want to show that if we do Docker PS, we don't have any container. And if I go and do that, remember these are the only containers, those have been a while. So now let's go ahead and create again Docker run dash IT CentOS bin bash. Now let's go ahead and run that, create our first container here. And as you can see, we created the container. Uh, Okay, now if you see our prompt, which was earlier as a local admin at Ubuntu, now has been changed to root at some randomly generated alphanumeric, So that means now we are inside a container. And as you can see, when you run a container, it runs as a root user. That means you don't have to elevate your privilege or anything. So we can see it has its own directory structure and everything. If I do if I want to see the IP errors, if I can type the IP config, yeah, there is no command if config. Let's say type a curl command, okay, wget. There are a few things, so there is nothing inside that one. Now you are within a container, but there is nothing on this container. And if you see, the type of this container is what? It's a CentOS. But see, our base operating system is what? Ubuntu here. So I have a quick question for every one of you. If I want to install some package on this container, do I need to use the yum command, or do I need to use the apt-get command? Anyone, any guess? Hopefully you guys understood my question, that our base operating system is Ubuntu, and this container that we created is based on CentOS. Now if I want to install, let's say, the wget as my package, so do I need to use the yum command, or do I need to use the apt-get command? Anyone, any guesses? No one wants to guess? Okay, if no one wants to guess, that's fine. So let's go ahead and try typing both the command and then see what happens. Okay, Maddie guessed something. So let's see, Maddie, do we need to type yum install or something else? So let's go ahead and see if there is a yum command on this one. Yeah, there seems to be yum command, but let's see, do we have an apt-get command? No. So yeah, so what Maddie said makes sense. So that is right. Now, even though the base operating system is Ubuntu, but the container is based on CentOS. So now you think that you are working on a CentOS based VM or a machine or a physical server. So you would run all your CentOS command, not your base OS command, like the Ubuntu command. So the apt-get will not work here. The only command that will work here is your yum here. Okay, so now I will go ahead and exit this particular container. And you can do something, whatever you like to do from this particular container. So you can see that I can ping, and we can go ahead and install wget. And right now it's updating my CentOS and some of the other things. It says, okay, hey, do you want to do that? And I'll say, okay, yes, go ahead and install this package, accept all of these keys. And now you see earlier I had issues with the wget, and now I went ahead and installed the wget command. Yeah, pretty cool. How long it took us to start a CentOS machine? Maybe just few minutes. Instead of going ahead and creating that VM, mounting that ISO, probably installing and selecting each and every package that you need probably. So a whole, we save a lot of time. So, the efficiency and some of the other thing improve. Now let's go ahead and exit out from this one and see what happens. Once you exit, you are pretty much thrown back to your host operating system. So now if I go ahead and run a docker ps command, what? There is no Docker container. Why? We just created a Docker container. No, but remember, when you exit a Docker container, when you run an interactive shell and when you do an exit, you're basically exiting from a Docker container. That means you are terminating your Docker container. So that means that Docker container is no more running. So if you want to see the Docker container, you would have to go back and run the Docker ps, and you will say Docker ps-a. And as you can see, the first line here, sorry, the first one here, that it says, okay, hey, this was the container ID. It was based on the CentOS latest. The process that we ran was the bin bash. That was 4 minutes ago, and we executed it like a 40-second ago. And the name of that container was, wow, it's a pretty nice name, Romantic Allion. So yeah, again, we didn't specify a name, so that was randomly generated. So something to keep in mind, when you run a Docker instance, or a Docker container, and if you do exit, you're just basically exiting or stopping that container. Okay. Now, if you want to see, like if you recall when we ran this command, Docker info, one of the thing it shows, okay, the root directory was warlib docker aufs. Okay, and if you look, this is my container ID, so it ends with 2f37. So we can go ahead and look at this directory and see, do we see this file or not? So we can do warlib docker aufs. I would have to run this command as sudo. Sorry guys, my machine is a little slow. Now there are three directories within that. There's a diff directory, there's a layer directory, there's an MNT. So let's have a look at the diff directory here. And within the diff directory, there are so many things, okay? And we are interested in what? We are interested into 2f37. Let's see, do we see anywhere 2f37 or not? So 2f37. I can grab, I know, but let me just quickly have a look. 2f37. Okay, maybe I can grab, but yeah, let's say I don't want to spend time on this one, but yeah, again, you can go ahead and look all the files that anytime you create a container, the this is the directory where it gets stored, or this is the place where it uses as a storage on your host operating system. So just something to keep in mind. And if you don't remember this path, don't worry. Just go ahead and the docker info command. It goes back to root directory. Do ls on your root directory, and you can go back and make sure check your container ID from the above one. There are a few cool commands with the Docker, like we just did a Docker PS. Let's say you created a Docker container and by mistake we exited out. So we have stopped the container. So that means when we do a Docker PSA, the container is still out there, but it's no more running. So that means if the container is there and if it stops, so what you can do, we can go ahead and start a container. We can stop a container. We can restart a container. We can remove a container, and we can attach to a container also. Okay. So we can use pretty much any command. So let's go ahead and we can say, hey, Docker start and give the container ID that you want to start. Okay. And now if you run the Docker PSA again, what it says, it's up from the last 33 seconds. And if you just do a Docker PS, it says, okay, hey, now you have a Docker container which is running. This is the name of the Docker container. It's been up for that many number of seconds. This is the command that's running is based on this particular image. Again, I said you can use start, stop, restart, attach, or RM command. If you want to remove this container completely, you can go ahead and use the Docker RM command. So for that, let's go ahead and stop this container first. So I'll go ahead and stop the container. Once we stop the container, it's taking a little while just to make sure everything is shut down properly on the container. Now, once that is done, we run the Docker PS again. It's no more running. Just do a command and we can see, okay, hey, this was the Docker container, which is stopped. Now we decided to remove this Docker container because see, this isn't just the stop state. That means it's still consuming the space on our Docker host in terms of that AUFS directory. If you want to get rid of this completely and want to free up your space, you can use the Docker RM command. Docker RM and your container ID. So now it's gone, and if you do the Docker PSA, you won't see that anymore. So that means this Docker is no more exist on the system. So you cannot do any kind of start, stop, or restart. Something to keep in mind. Pretty, cool. Again, we learned that earlier. If you want to remove an image, you would use the Docker RMI command instead of the RM. RM is for the container. I is for your image. So let's say again, let's go ahead and create our container one more time. So I will show you one more thing here. So I'm just doing a backspace here. So I'm doing again Docker run it CentOS bin bash. So we are creating a new container based on the CentOS image, again interactive and TTY, and we want to run the bin bash process. As you can see, the root at some random generated number, that's the host name, that's our container ID. Now, if you type exit command, it's going to kill your container. If you want to detach, if you want to come back, or if you want to get out from this container without killing the container, you would have to use the control PQ command. So you would have to hold control P and Q. That would brings you out from your container back to your host operating system. So if I do a Docker PS, you will see, okay, hey, we have this container running. And if you want to go back inside the container, you would use the Docker attach and the container ID. So we'll type Docker attach and the container ID. And now we are back inside the container. So something just to keep in mind that there are commands with the Docker. You can use start, stop, and restart, RM and RMI. Now let's go back and we learned earlier the RMI can be used. So now let me go ahead and start another Docker container, and I don't want to kill, but I just want to come back to the host operating system to control PQ, and I'm back. Now if I do a Docker PS here one more time, this is the container which is running right now. So you can use a command by okay, now go ahead and type here a Docker top. So if you are familiar with the top on the Linux, and let's see what happens if I do a Docker top here and go ahead and type your container ID, it shows you all the process pretty much running on that container. So you can see on that container, there is one process. The user ID of that process is root. This is the PID, and some of the other details. If you want to see the logs of a container, you can type the Docker logs and the container ID. So there were, unfortunately, there is no logs for this one. If there are any container, we'll go ahead and build some container where we have some logs. So we'll go ahead and show you some of the logs. This is a very useful command. So go ahead and type here Docker inspect command. and the container ID. So this command returns a whole lot of output, which is pretty good. So if you look in this output, it says, okay, hey, what was the command ran? Bin bash. Okay, what are some of the details? What is the path, that it's using? What was the base image that was used for the creation of this container? So it shows, okay, hey, this was the CentOS. Who is the vendor, CentOS? Look at some of these good details. This is pretty handy, like, okay, the host name, the ID, the image, the log path, volume, and look at, okay, these are some of the network details. So this command gives you a pretty good detail about your Docker container that can come very handy when you're building new containers or trying to troubleshoot or just trying to locate some of the things, that you're not able to find. Again, we have been talked about multiple times the Docker, the repository. So the official link for that is, I mentioned earlier, it's hub.docker.com. So you can go ahead and look all that kind of information out there. And it's pretty good. I would highly encourage you to go ahead and install the Docker on a laptop or something and then, play around with some of these commands. I'd like to take a pause here if there are any other questions or anything, this is what I had planned to cover in today's session. I know we are a little early. I said 2 hours, but I'll give you back again in 20 minutes or something. Let me know if there are any questions. Please post them to the Q&A. Okay, so one of the attendees is asking if I want to install some application, it's available to all Docker containers. In that case, can we install the apps on Docker Engine? Whether it will inherit from Docker Engine to Docker containers? No, nothing will inherit. So nothing will come from your Docker engine or Docker host to Docker container because the containers are completely isolated from everyone, except the container only has access to the kernel feature. So it's talking to a kernel, but not any application. Let's say on the Docker host, in my case, it's Ubuntu. And let's say you install a LAMP stack. Now you want to create a container and you want to access that LAMP stack on the host. No, that's not possible. So you will go ahead and create a new container, and in that container, you will go ahead and install your own version of LAMP stack. So that's the whole idea. Everything is isolated. And we don't want to install any of the things or really nothing other than the Docker engine on the host machine. That way you are not utilizing the resources unnecessarily on the host, and you are leaving those resources for your containers. That way you can run many more containers and install any necessary application that you need. That's the only thing I want to say. Hopefully that answers your question. If not, let me know. I can add some more details. Thank you. Thanks, Maddie. Any other questions on the Hangout viewers? Do you guys have any questions that you want to ask? Post them to the Q&A, or you can ask live. Okay, if there are no questions, so let me just go ahead and share those two URLs that I discussed earlier. I would highly encourage you guys to read these two URLs. Has some pretty good details, so I'm posting them onto the chat window. Let me go ahead and post one by one. It's not allowing me to post both at the same time. So this is the first URL. No, somehow it's messed up or what's going on. Okay, guys, this chat feature is not allowing me somehow for some reason these URLs to be shared. So I'll go ahead and post this URL back onto the Facebook Docker training page so you guys can go ahead and access these two URLs. And again, I would highly encourage you to go ahead and read these two URL. Will give you some very good details about some of the good differences and some of the other things. And with that, I would just like to thank everyone for joining today. And if there are no further questions, I will go ahead and close out this session. Okay. So thank you so much, everyone. Have a good day, good night, and good afternoon. I'll see you guys tomorrow. Take care. Bye bye.